Well, welcome to, I think it's the final keynote. Yeah. So I think we're saving one of the best for last. While all the keynotes have been really, really great. This one I'm especially excited about. I actually reached out to Joe myself to try and get him on here. Last year we had a kind of a smaller version of this summit, probably more for internal contributors. And Joe gave a really, really exciting talk last year that I think a lot of folks kind of walked away with a lot of knowledge on from a more of using Dask in an operational and production setting. So Joe is from SymphonyRM. He's the CTO there, where he's really helping to provide machine learning abilities and capabilities across his enterprise. And along with him, Jie Lou is going to be presenting. She's a machine learning engineer at SymphonyRM, and in the past 2 years, she's helped the team successfully build scalable machine learning and data pipelines. I believe they'll be talking about using Dask in a production setting, but I'll let them kind of talk to what they'll be speaking to and then give their own introduction. So thank you, Joe. Thank you, Gia. We're really excited to hear your talk.
Awesome. Thanks so much, Jake. We really appreciate the opportunity to be here. And we're going to talk today about not just Dask, but another platform called Prefect. That's a data workflow platform. And we've used it to great success. So we're going to get into some details about that. We work in healthcare. We kind of put machine learning into productized offering for our clients. And we subtitled this talk, Superpowers for Data Scientists. We are a small team, so we got to do a lot with a little. And Gia in particular has done some great work in terms of packaging up this infrastructure, making it really productive for our data science team. So with that, we'll give you a little bit of background about us. Gia, you mind saying a little bit about your background?
Sure, yeah. Hi, everyone. My name's Jie, and I'm a machine learning engineer at SymphonyRM. My main focus area is machine learning pipelines and infrastructure. Before I joined SymphonyRM, I graduated from Carnegie Mellon with my master's degree in information system management. I'm delighted to have the opportunity to present today with Joe and looking forward to the further discussion.
Thanks, Gia. Yeah, Gia's done some great work. You know, some organizations have a whole machine learning department. For us, we're a little bit of smaller startup, and Gia is our machine learning department. So she's done great, and our team of data scientists really appreciate all her efforts. Sometimes I joke that the data scientists are going to commission a statue of Gia out in front of our headquarters because they're so appreciative of what she's done. Just really quick background on me. Done a lot of time at startups, really enjoy working for small innovative technology companies. And then really my focus the last decade has been around how do you put machine learning into a repeatable product? All that work's been in Python. The last 5 years I've been here at SymphonyRM, and then 5 years prior to that, we did a startup focused on machine learning for fraud detection for big banks, and that company was acquired and then came to SymphonyRM. We are going to talk about Prefect. We've had a really great experience. They've been a great partner for us. So some of this might come off as it might sound like a Prefect commercial. So we did want to disclose what the full extent of the relationship is. So there's really two pieces to it. One is we're a Prefect customer. They have both a free open source offering and a commercial cloud offering, and we are a customer of their cloud offering. As part of that, they send us swag as thank yous, like hats and shirts and stickers and blue rubber ducks. And then the other piece of the relationship is Prefect has a pretty large technical advisory board made up of people from across all industries, and I'm one of those members. And as part of that, I get a little bit of equity in the company. So we just want to be fully transparent on that. Okay, so what are we going to talk about today? I'll cover the first two parts, and really we're going to kind of tell this as a story. Like, how did we come to use this combination of technologies of Dask and Prefect? And then in the second part, I'll talk a little bit about how we did that original R&D a couple years back and how we found that and why we navigated, to this combination, and a little bit about what it means for the business. And then really the meat of the talk is going to be Gia taking you through, like, all right, let's come back to how we use it now. How do we put this into practice? How do we make use of it? How do data scientists use it? Things like that. And then we'll have a little bit of a wrap up and maybe a few recommendations at the end. Great. So before we dive in, you have to know a little bit about our business. We'll keep this brief, but the short version goes like this. There are many challenges in healthcare in the US, of course, but one theme has been it's traditionally been very reactive. So healthcare organizations kind of waited for people to become sick, come for care. And for many reasons, that's changing in a good way, and that they need to be much more proactive. And they're also sitting on a lot of rich data. And traditionally, they haven't been advanced users of analytics and data science. They're catching up rapidly. But that's a big part of what we do is we help our clients in healthcare be proactive. And just as a really simple way to understand it, we bring together a lot of different data sources, starting on the left in healthcare, there's a lot of siloed, messy data, but it's really rich. And we bring that data together, we assign some actions to patients and do some prioritization, and then we help our clients proactively do outreach. So this would be send campaigns, send emails, text messages, call them, things like that, to bring them in for care. And this could be really simple things like annual wellness visits. It could be things like what are called care gaps, like diabetics should get an A1C test to check their levels of their blood every so often, things like that. And for the first several years of the company, we were focused on these existing action sources, meaning some other system had already indicated like this patient needs this particular kind of care, and we were helping our clients reach out to them. So no fancy machine learning, really simple kind of connect the dots type of thing. But we always had a vision that that data would be really rich and predictive. And so late in 2018 and coming into 2019, we had this imperative where we really wanted to make a bigger push into do model-based action assignment. So using machine learning, especially around clinical data like procedures and diagnoses and lab results and medications and vitals, really rich data, could we assign actions? And the second piece is really critical. In machine learning and data science and healthcare, a lot of companies have a very niche focus, and a classic example is like, there are companies that just detect tumors in images and help radiologists. That is not us. We have a much broader mandate where our client said, we really want you to help us across the board. So it could be things like cancer screenings, orthopedic surgeries, chronic conditions like COPD and diabetes. So really, we had this ambitious vision to cover a lot of different disease areas. We had a really small team. We were essentially building out this data science effort from scratch, and we had a lot of time pressure to go to market. So I felt tremendous pressure to climb this, seemingly insurmountable mountain. Jie, I had two quick questions for you just to put you on the spot. You were a new grad, joining us full time. Did you feel much pressure, when you joined and were part of this, big challenge?
I think I had the same feeling. And I think I remember at that time we felt like parallelism would be the key of the success, but really had no idea how we could achieve this goal. So I think the pressure, I also had a pressure on my side.
Well, I hope it wasn't too much pressure, but obviously we got to a great result. So I'm really happy about that. One quick editorial. We feel like this is actually a great application for machine learning in healthcare in the near term. And why do I say that? We do not change the clinical workflow. So our predictions are not going to physicians asking them to have surgery based on one of our model outputs, not at all. We're kind of like a matchmaker. We have predictions and recommendations that say, patient X, you should really talk to your doctor. We kind of get them together and have this proactive effort. So we think it's an area that our clients can go really fast in. It's really low risk, and that the intervention is really benign. We're essentially saying like, hey, patient, come in. We think you might benefit from XYZ, and have a discussion with your doctor or your care coordinator or your nurse. And then the second piece, really quick, there is a big fairness and bias aspect in all of this. That's out of scope for today's talk, but shout out to our team, especially Chris Hemphill, Ling Hong, Yuki Ito have done great work along with others. We have a nice collaboration with University of Chicago Booth School of Business Center for Applied AI, where we're collaborating with them on fairness and bias aspects in this. And that was spearheaded by Chris, so shout out to them. Okay, so let's get into a little bit of technical context. So here's how we came into it. We had done work in ML in Python back from that fraud detection company I mentioned. And then at SymphonyRM in the early years, we did a lot of data engineering work. So I mentioned we kind of bring together all these messy data sources, and we did this in this platform called Airflow. You build these, often you'll hear them called DAGs, for directed acyclic graphs, but you can think about them as multi-step workflows where steps in the workflow depend on other steps. And we had a lot of success in that model, and kind of conceptually we thought about things of defining these units of work, these complex multi-step units of work, and being able to run them repeatedly, which is a really great fit for a variety of data processing tasks. It's no surprise that those workflow platforms are gaining huge popularity because they're such a good fit for the problem space. And then lastly, we were big users of Amazon Web Services, and we also had HIPAA compliance requirements, of course, in healthcare that we implemented on top of AWS. So one last piece of context, then we'll finally get to some details around R&D. Here's how we thought about our requirements going into R&D. Number one, we said we got to let our data scientists work in Python. They're really productive in that. They're comfortable. The tooling is great. They just love that ecosystem. So that was a must. And just like Jie said, parallelism was going to be key. So being able to run a lot of experiments fast to scale up and cover these many different disease areas. We're looking for commonalities. We're working with clinicians and domain experts. How do we embody that in the ML and experiment across many different disease areas and for many different customers? That was not enough, and that we also had to eventually productize it. So not only do we need to do the R&D and get breakthroughs on predictive models, but we got to be able to deliver it in a repeatable way. So building up these pipelines that we can run repeatably was really key. And maybe the short way we thought about it is we wanted to make our data scientists really productive and give them what we call kind of superpowers, give them the best tooling so that we can not only have those R&D breakthroughs, but then productize it and deliver it. So pretty big challenge going in. Okay, so let's go back to how we actually did the R&D. So I'll quickly take us through this. And what we started on in the beginning of 2019 is we actually started with Dask. So we looked around and said, like, parallelism is key. The things we were hearing about Dask was really positive. So we did a prototype on Dask. And here were our observations. So the first two were really key, and we had a great experience. We could create a cluster in AWS. We used the Dask Kubernetes project. We could scale it up and down, and that was relatively straightforward. We could run our Python code in parallel on the cluster, and this was a huge step. It was a big, eye-opening thing of like, we can really do this. The tooling is there. It was so encouraging to run that first few set of prototypes. But we did notice a few things that were kind of so-so. So certainly Dask is not a workflow system. And we thought in terms of these workflows from our experience on Airflow, and we observed like, all right, it's not quite the same tooling. It's not intended to be, but we're not going to end up building these really workflows directly on Dask APIs. And there were just some other, nuts and bolts things like tracking errors, collecting logs that sit out on workers. Dask doesn't address that directly. Parameterizing the workflows, it's doable, but we'd need to build up some tooling there. Retrying tasks also doable, but we need to handle some of that ourselves. And getting code out to the cluster. Dask doesn't address these kind of things directly, and nor is it intended to. So our observation was we were super encouraged just with Dask. We knew that Dask was going to be part of the solution, but we had this really fortunate timing in that Prefect open sourced their initial version in early 2019. I think it was February or March. And we quickly took that open source offering and we tested it out on top of the Dask cluster that we had built out. And we were super encouraged. It really gave us the workflow type paradigm that we thought about. It was really easy to build these workflows. It was much easier to track errors by task and flow. Like we might run thousands of tasks and 3 of them would fail. And how do we go dig out those particular errors across all those tasks? It did a bunch with log collection. It was really easy to parameterize that flow. You could just ask it to retry tasks, and we could still get all of the capabilities of Dask. So, and we could run this, by the way, we could run it on a long-running cluster, or we could spin up clusters on the fly that are ephemeral. So for us, this was kind of like a chocolate and peanut butter type moment of that combination felt like what we wanted. We could define these workflows. We could get the advantages of really powerful parallel compute. And that seemed like the right paradigm. Now, I struggled to like fully explain, like, what do I mean by right paradigm? And I was trying to think about words to do it. And I came up with some visuals. This is the first time I'm presenting this, so we're going to try this out and see if it works. So if you go back to the first automobiles, it turns out the way that you move the wheels, the way that you steered is with this lever thing. It's called a tiller. And obviously it was borrowed from boats and rudders. And that was the first thing. That did not actually last very long because the way I understand it, in 1894, the steering wheel was invented. And now after a century of innovation, they're really sophisticated and fancy and look like that. And what I like about this analogy is we can think about like the steering paradigm. What's it like to steer the car? What's the kinesthetics of that? The steering wheel is such the right paradigm. Two hands on the side of the wheel, the pull down, push up. You can get really precise steering. And we think about the other one, the tiller, it's terrible. It's exactly the wrong paradigm for steering. So no surprise it went out the window. Now, how does this apply to Dask and Prefect? We're not saying Dask is the clunky contraption on the left. In fact, our view is Dask is actually like the car, this powerful Porsche on the right, super capable, huge performance envelope, incredible capabilities, but for workflows, for this particular scope, it doesn't ship with this fancy steering wheel. And in fact, my speculation is for people that are doing workflows on Dask, they probably have kind of cobbled together their own steering wheel. In our observation, if there's one thing that we want you to take away from this talk is that in our experience, Prefect gives you that like great interface if you're working in that workflow paradigm. Not everything that people do on Dask, of course, fits that workflow paradigm. But if you are working on something that fits that workflow paradigm, our experience has been really positive with Prefect, and we'll go into a lot more detail about what that means. Okay, so just wrapping up our R&D, what did the first flow look like? This is a simplified version. It's completely what you would expect for a machine learning flow. You know, we extract some data from a data warehouse, and then we think in terms of feature sets, so groups of features, especially in the clinical world. These could be things like lab analytic results that are really rich, patient demographics, vitals, meds, encounters, procedures, diagnoses, things like that. And then we can merge those features together, apply some labels, and do your train tests and store results, exactly what you would expect. But there are a couple of things that I would observe. So one is that this is really parameterized. We could focus on certain feature sets and not necessarily generate existing ones. If a data scientist is working on labs, maybe they're only focused on that piece of the puzzle, and we can map over those different feature sets. And it's highly parallelized. Everything you see that's designated with a map can run in parallel in Dask. For us, data scientists do work in Jupyter notebooks. It turns out people have really strong opinions about notebooks and whether they should run in production. It's out of scope to go into that debate. I would say for us, we've adopted more the Netflix model. And our take is our data scientists are kind of the customers of this infrastructure. They actually like notebooks. They find them really productive and powerful. And so we kind of meet our customers, our internal customers where they are. So what did we get out of this effort? We had two big results. So first is we dropped our benchmark experiment time from 2 days to 30 minutes. No surprise, it's really embarrassingly parallel problem. So we get this huge speed up, really productive for data scientists. And most importantly for the business, we got to dozens of successful models in about 6 months. So really great breakthroughs. And you can see on the right, the variety of things we do. Our clients are not sophisticated data scientists, so we don't tend to talk in terms of precision and recall and F1 and things like that. We tend to talk in terms of how much lift can you get in the top decile of scores. If you took the top 10% of scores, how much better than average would good candidates of patients be? And you can see, around 10x lift from that. So really rich, good pools of people to reach out to. A little bit about the Prefect UI as I wrap up this section. I just wanted to highlight, I grabbed these screenshots yesterday, and here's what I think is one of the powerful things about Prefect among many. So here's a really simple flow. This was a hyperparameter tuning one. There's actually not many steps, but in the train test track step, it ran 122 tasks across the cluster. Most of them succeeded, but 7 failed. And we can go and look up the tasks. We can filter for the failed ones, and we can go and look at the logs. So not just the stack trace, but you can look at the logs in context, and you can just kind of scroll through this. I didn't add much of the log, but you can actually scroll through the log for that particular task to get the context of what happened for those particular failures. So really productive way to do that. And then last piece for me, like I said, we think about our data scientists, kind of our internal customers. This is Andrew on our team, longtime ML guy. And I'm not going to read the whole quote, but what I love most about it is the part that we bolded, where he says he can focus on feature engineering, capturing clinical domain expertise, ML model tuning, and not on infrastructure, which is exactly what we want. We want to let data scientists do the work that they love to do and not mess with infrastructure. So really happy with it, with getting to a place where that's the case. Okay, so that was all the R&D, just a quick summary of that. Now we're going to skip ahead to today, and Jie will take you through how we use Dask and Prefect currently, and then I'll sprinkle in some comments as we go. But I'll turn it over to you, Jie.
Thanks, Joe. To start with, I will first talk about 3 main machine learning pipelines we have already built. As Joe introduced, the flows are all parameterized and scalable, powered by Dask and Prefect. So first, I will talk about feature engineering flow in the next slide. This is the simplified version. It loads and manipulates data, doing labeling, preparing for the model training. The pipeline is built on Jupyter notebooks, and Papermill executes the notebooks and have output notebooks for data scientists to review and debugging. On the left, I put some code for you to give you an idea how easily we can build a flow using Prefect. Each task here just calls Papermill API to run notebooks 1A, 1B, 2A, 2B, and 3A. You can imagine A and B represent different data sets like demographics or medical history. And 1 is the step that extracts data from storage, and 2 is the step of feature engineering. And finally, 3A merges all the features into one final feature matrix. And here we also take advantage of parallelism. As you can see, there are 2 subflows. So one is do feature engineering on demographics data, and the other is on the encounter data. Since they are independent from each other, we can process them in parallel instead of running them sequentially. And in our production flow, we also have tasks working on medication, on lab orders, or etc., and which will be like 1C, 1B, or 1D. And we have client and batch as parameters of the flow so that the pipeline can work for all the clients and batches for version control purpose. So here, data scientists not only focus on the notebooks itself and don't worry about the flow. And on the right bottom, you can also see a Prefect UI for this flow. So data scientists can easily manage the flow from Prefect UI.
And then I was going to explain just quickly this naming convention. Credit to Andrew who came up with this. So this is just a kind of smaller version. Our actual flow is much larger. We don't want to show the whole thing for competitive reasons. But the concept is you have many pieces, and you kind of represent this in this 2D grid where the columns are these data sets. And for us, it's very natural to have slices like Jie said, like labs or meds or vitals or encounters. And a data scientist is probably not working on all of them. They're probably working on one area, like I'm going to improve feature engineering for labs. And then steps in the process, obviously, are as you go, extraction, feature engineering, merging, train test. And so this gives us a way to quickly refer. And data science is a very common thing would be like, hey, I just edited, feature engineering for XYZ. I want to run 1B, 2B, 3A, and then 4ABC. And then we have a shorthand way to refer to that in our parameterization so that just those portions execute, which is really nice.
Yep. And next we have Hyperparameter Tuning workflow. Data scientists use it to pick up the final model that performs best on the test data. We usually have to search the best ones from thousands of candidate models. And here we still benefit a lot from parallelism. And I will not go too much detail for now because we will zoom in this flow later. Basically, the flow has been streamlined to make a data scientist's job easier. They just need to specify the client, clinical model they want to train, and a JSON file will be generated automatically for the experiment. And we use scikit-learn, XGBoost, Keras for model training. And MLflow is another important framework for tracking the results so that data scientists can compare the results when the experiments are done. Okay, last, we have a model training report pipeline for data scientists to train the model with the best parameters selected from Hyperparameter Tuning flow. The flow starts to evaluate performance, analyze model bias and feature importance, finally generate a training report. And when the flow is done, a message will be sent to Slack channel with a link. The report is stored in S3 for data scientists to review and track. And on the right, you can see a snippet of the training report. It has all the information from hyperparameter tuning to the final model selection with all the useful links of output notebooks. And data scientists can just click the link and review the model results. To use this flow, still they can just go to Prefect to kick off a flow with parameters. It's flexible to choose any notebooks to run. They can also fill in the selection criteria to explain why they choose the model with MLflow run ID. Then parameters and the meta info will be extracted from MLflow directly. So these are our 3 big flows in the team. And our goal of pipelines and infrastructure is to free our data scientists from manual and repetitive operations. So in early times, data scientists have to copy, paste, or move files around different directories, which costs extra work and time. The pipelines and workflow has been designed to reduce these pain points so that data scientists can focus on training better models and analyzing data. Our data scientists do not worry about the technical details of infrastructure. The flow is already there for them to use for any client and any clinical model. Most important, we take use of parallelism to speed up their experiment to the great extent. So next, I will dive into some technical details on how we use Dask and Prefect in two cases. The first case is interactive. Imagine data scientists make changes on the notebooks or other configurations, and they would like to test it for the pipeline. We want to provide them an efficient infrastructure to experiment with. And when they're ready to put notebooks and code into production, the flow should be reliably scheduled. In both cases, we use Dask Cloud Provider project to create cluster resources in AWS. Okay, here, let's see the interactive use. It's time to dive into Hyperparameter Tuning flow. Data scientists first launch a cluster using our IPython widget. It is extended from the existing Dask widget, but with more functionalities. When the cluster is started, users can run flow, and data scientists have full control of this cluster using the widget. First, let's see how data scientists launch that cluster. As I mentioned, Dask Cloud Providers allows to manage Dask clusters on various cloud platforms, and we use AWS as our provider. If the task is not memory intensive, then we use AWS Fargate. Here you can choose memory, CPU, and a number of workers. If the task requires high memory or GPU for neural nets, then we can use AWS ECS cluster. AWS ECS is a fully managed container orchestration service, and Fargate is a serverless compute engine for containers with memory limit of 30 gigabytes. And shout out to Joe here. He contributed to this project to enable multiple Dask worker types. We also plan to make a pull request in the near future. Okay, so after the cluster is launched, data scientists can always adjust the number of workers using the widget. When the cluster is ready for use, they can also see the number of workers, cores, and the memory. And dashboard link would also be useful for them to monitor the whole progress. Data scientists can also interact with workers by running commands. Suppose users want to pull the latest code on the workers, check the files, upgrade the package. They don't have to rebuild the whole image, restart the cluster. They can just test on the current one. And finally, when the experiment done, they can close the cluster. Data scientists can also see check agent. So prefect agent is a process required to run prefect flow successfully. And data scientists here do not need to worry about it. It has already been handled by scheduler as well. They can also check the log of agent if needed to see if the flow has been already submitted. Okay, this slide shows the dashboard. When the hyperparameter tuning flow is running, data scientists can monitor the whole process, check the health of workers. And they can also monitor the process from Prefect UI. And all the experiment results go to MLflow. Here I show the MLflow UI. And finally, when the experiment is done, data scientists can also analyze the results to compare the model performance and finally select the best combination of parameters from Jupyter Notebook. So in conclusion, we are empowered to train models in parallel, saving data scientists a lot of time in waiting for the results. They can also interactively test the changes. It's also flexible for them to update workers and the scheduler interactively. This provides an efficient infrastructure for them to develop code and run experiments. Okay, next, I will briefly show our production use. When data scientists are ready to put notebooks or pipeline into production, we have already built the flow. They can just easily change the configuration of resources to set up the number of workers, CPUs, and memory to run the flow. And when they check in the notebooks, Screwdriver, our CI/CD tool, is triggered to build an image and deploy the flow. Okay, so I think that's to the end, and that's all I want to show for today, how we use Dask and Prefect, these two powerful tools to build machine learning pipelines efficiently. And I will hand back to Joe now.
Awesome, thanks, Jie. All right, just a little bit of wrap up. So the first thing we want to say is that Dask and the greater PyData ecosystem has been super successful for us. We're really appreciative of the community. Our view is the technology is great, but also we've had a really good experience in the community. We find it to be a really open, supportive community, and we're heartened to be a part of it. It's been a great choice both for our business. It's unlocked a lot of value for our clients. We're helping reach out to patients and keep them healthy, and it's really good stuff. And our team has just benefited a bunch from being in this ecosystem. It's great to see a lot of investment. Feels like it's never been better. We're really encouraged. And then, of course, your takeaway is Dask and Prefect have really become the heart of our machine learning stack. They're really core to what we do every single day. It got us both that interactive R&D, those early breakthroughs to get to predictive models, and now it's the heart of how we run this machine learning powered product. And it does deliver on that vision that we had originally for superpowers for data scientists. A couple of quick thoughts and recommendations. Dask user, if you have something like a workflow, I would encourage you to just try Prefect, give it a shot. It's really easy, just pip install Prefect. The open source platform is really easy to work with. The documentation is great, and they have a great community too. They've been a super supportive partner. One note, Jie showed our own IPython widget that's a little bit customized to what we do. No need to build your own, just try Coiled. They were kind enough to give us an early preview, and their stuff is great. It's much better than what we have. It's just we had some specific requirements, especially around those heterogeneous worker types. So we did our own thing in the short term, but they have a great solution that you should go check out. And then for anybody using heterogeneous Dask worker types in a single cluster, we would love to talk. We do have, Jie mentioned, we forked Dask Cloud Provider, and we have some functionality to let us spin up those different worker types in a single cluster. And I'm behind on submitting a pull request for that, but we'll do that in the near future here. So the last thing I'll leave you with is just the Prefect aspects. This combination of technologies has been really good for us. So I'd encourage you to go take it for a spin. So thanks a lot. Just one other quick thank you. I wanted to thank the organizers. When Jake reached out about doing a talk, I said, I would love to, but I really want to highlight my colleague's work. That Jie has been doing just some great work on all of our ML infrastructure. And he didn't miss a beat and was super supportive and said, yep, absolutely. So I really appreciate you making time for both of us today. It's really nice to get some more voices in here and give Jie a chance to speak about her great work. So thanks for that. And that's all.
Yeah, no sweat at all. I mean, first of all, we asked you maybe 2 or 3 weeks before the conference, and you were like, yeah, we'll both jump in. We were ecstatic that you accepted under such a short timeline, let alone brought in another great voice. So thank you both, Joe and Jie. So we got a few questions. I don't think there's a ton, but I think we can also maybe answer these here and then jump in together, I think we've been doing with most of the keynotes. And if you do have a question that you've just kind of started sparking up, feel free to throw it in the Q&A section, and then we can just kind of handle them here and then maybe have a little bit more of an ad hoc conversation and gather. So first question we got was, what's the difference between Prefect capabilities and the Netflix stack?
Yeah, I can talk about that one. The way I understand it is, and our reference to the Netflix approach was around the use of notebooks and kind of automating notebooks in your production infrastructure. So I think Netflix is famous for, hey, they let data scientists work in notebooks and then they automate those notebooks. To my knowledge, I don't think Netflix uses Prefect yet or today. So it's just that they're focused on automating notebooks in production.
Yeah, that makes sense. And then another question out there is another one around Prefect. It's how would you compare Prefect with Airflow or Luigi?
Yeah, so I can talk a lot about the comparison to Airflow. I'm less familiar with Luigi. my quick sense on Luigi is it's a much older project, kind of similar to Airflow, came about around the same time. So we have a lot of experience with Airflow. The big challenge and the thing that really excluded Airflow from even consideration for our data science flows was around scheduler latency, like the time between tasks. Traditionally, that was really slow. And the scale out, there were ways to make Airflow scale out, but we felt we couldn't achieve the performance considerations, especially around really fast iterations over thousands of tasks. There are a bunch of other aspects, like how easy is it to pass data between tasks? And maybe a shorthand way to say it with a little bit of history, this will help give context, is the founder of Prefect, so Jeremiah Lowen, was a committer on Airflow for a long time, kind of knew Airflow in and out, and had some ideas on how to make that better, and worked on submitting some of those ideas. I think they were a little bit slow to get uptake in the Airflow community, and Jeremiah ended up, there was kind of some demand from other of his colleagues and things, and ended up doing a separate company and platform around that. And I should note, Airflow is getting a bunch of upgrades. There's a 2.0 version. I'm not super familiar with the latest capabilities, but I can say like our experience on Prefect has been fantastic, and both the technology and the community and their partnership.
Cool. Another question here is, how large is a single cluster you spawn for a medium ML task?
Yeah, Jie, keep me honest. I think the largest we've tended to do is 100 nodes. Each of those nodes could be pretty high powered. And the one thing you saw that's a little bit unique about us perhaps is we have portions of our pipeline that don't require a lot of memory. We have a few portions of the pipeline that do require a lot of memory. They're a little bit bottlenecked. So we'll often have, most of our workers would be maybe under 30 gigs. And then we need one worker that's really big, maybe like 100 gigs or more of RAM. And we need to kind of funnel the pieces of the process through that. And Prefect actually makes it easy. You can tag tasks with Dask resource tags, and those tasks will execute on Dask workers with those resources. So we use that for like high memory or GPU. But cluster size, we've stopped at 100. It's not really a hard limit. Maybe it's just our own kind of like mental limit. We could certainly go bigger, but for us, it's been about 100.
Another one is another infrastructure discussion. It's what makes you choose ECS over Fargate for a task?
Yeah. Jie, you want to say a little bit about this?
Sure. I think like for Fargate, it's easy to launch and we don't have to wait a lot of time. But the downside of Fargate is it has memory limit, and also you only have 4 CPUs as the maximum computing power. So it kind of like a trade-off between your like task resources and your and the time.
Yeah, and the nice thing about Fargate is it truly is serverless. There's no infrastructure running until you request it. So we use these for ephemeral clusters. ECS or EC2 launch type ECS, the terminology is a little bit confusing, but the non-Fargate version of ECS, you have to do a little bit of configuration. Like you have to have these auto scaling groups and EC2 launch templates, and you've got to kind of set up like, hey, these are the resources that we want to use. But the great thing is you are not limited by any kind of maximum RAM. It's any EC2 instance that's available on AWS you can use in a ECS, EC2 launch type cluster.
Another one, so I think this is a clarification. What's meant by the heterogeneous worker type?
Yeah, so what we mean by this is kind of by default, a lot of the Dask cluster managers will make you workers that are identical. So you might say like, I want 50 workers and I want everyone to have 30 gigs of RAM and 4 vCPUs, and every one of those workers will be identical. For us, because we have pieces of the pipeline that are memory intensive, we need at least one that's high memory, but we don't necessarily want to pay for, we could, spin up all of these high memory workers and have them identical, but we don't want to pay for all that. So we do this heterogeneous worker types where we might have a cluster of 50 nodes, 49 of them would be these smaller, 30 gig workers. And then we need one behemoth worker that has tons of RAM for that like last step in the pipeline or merge step or something.
A little bit of gamesmanship, which is good. Yeah.
Exactly.
It seems like Q&A we've kind of covered them. So if anyone does have any questions, let's maybe move that to GatherTown Jim, I don't know if you can share the link in, he's already a step ahead of me. So
Yeah.
yeah, if you want to jump into the link in the chat here, maybe have a little bit more ad hoc conversation. But before we go, thank you so much, Joe and Gio. We really appreciate the conversation. Just like last year, you guys, well, Joe, I know you were there last year, but Gio, you added a great talk to the conference here. So thank you so much.
Awesome, our pleasure. We'll see
All right.
everybody over
See you
here.
guys over there.